All right, welcome back to 1 a day 21. This is for Math 360. So this is example 1. And in this example, we are given the joint PMF of x1 and x2 for two random variables, and the joint PMF is x1 plus 2x2 all over 18, and x1 and x2 are able to take on the values of 1 and 2 respectively. Okay. With this joint PMF, let's go ahead and compute then the f of x1, and that is going to be equal to, let's see, we're going to sum over x2 here, so it's going to be all the values of x2, and we have our PMF in here, okay, and so if we throw those in, we're going to get x1 is going to stay here, and we're going to have x1 plus 2 times 1 over 18 plus x1 plus 2 times 2 all over 18, which means we have 2 plus 4, and so we have 2x1 plus 4 plus 2, so 6 all over 18. And then x1 here, of course, is equal to 1 or 2. All right, so let's look at the marginal f2 here. Okay, and so it happens to be that these two have the same form, even though we're summing over the corresponding opposite. So for f2, we're summing over f1, f1, we're summing over f2, or x2, sorry, is it f2? So this is going to be x1, which is going to be 1 here, plus 2 times x2, 14 plus x2, which is 2, plus 2x2 over 18, which is going to give me, what, 3 and 4 plus 4x2 over 18. And then x2 here is also going to be 1 over 2. Okay, so those are our two marginal probabilities, and we can note here that f of x1, x2, this is not equal to f1 of x1 times f2 of x2. This product is not the same, so what that means is x1 and x2 are not independent, aka they're dependent. Okay, so they are not independent for this problem, and so that means that they're dependent. Let's see, what else can we find? Let's find the mean and the variance for each of these. Okay, so mu1 is going to correspond to summing over x1 equal to 1 to 2 of x1, 2x1 plus 6 over 18. So if you compute that out with the marginal probability function, you get 14 over 9, and then sigma 1 squared would be the sum of x1 equal 1 to 2 of x1 squared times 2x1 plus 6 over 18 minus 14 over 9 squared. Okay, and so if you do the quick sum on this, and I was going to throw this into maxima, and I got 20 over 81 here. Okay, so there is the marginal variance and the marginal mean for u1 or mu1 and x1, or I guess for just x1, that'd be the easiest way to say it. So mu2 is going to equal sum of x2 equal to 2 over 2 of x2, f of x2, which is what we get there was 3 plus 4 x2 over 18. And so computing this, what did we get on that one? We got 29 over 18 because what we ended up getting on that one. And then the variance on the x2 here is going to be equal to the sum of x2 equal to 1 to 2 of x2 squared, and then we have 3 plus 4 x2 over 18 minus 29 over 18 squared. And if you compute that out, that comes out to be something super simple and something you would really just guess. This is just so obvious that it is 77 over 324. Okay, so there's our mean and variance for the x2. And now, boy, let's see if I can squeeze it in here. Okay, so let's compute then the covariance. So the covariance of x1, x2. This is going to give us, let's see, so we have the sum of x2 equal 1, 2, and then the sum of x1 equal 1, 2, of x1, x2 over x1 plus 2, x2 over 18. Okay, if we put all these numbers in, I think the easiest way for me to think about it is if you hold like x1 at 1 and then run over x2 and then run let x2 equal the next, x1 equal the next one, and then let it run however you see that. That's usually how I make sure I get all the values and try not to let it get too confusing. Oh, I forgot minus here. This is going to be 14 over 9 times the 29 over 18. I was getting excited by putting the equal sign there. So this is the mu1, mu2. Okay, now this equals 45 over 18 minus 406. Minus 4 over 6 over 162, and so this difference is equal to a negative, I think it's 1 out of 162 is what that turns out to be. So that's the covariance value, okay? And now we want to compute the correlation coefficient, rho. So we're going to have here that rho is equal to, this is equal to the covariance of x1, x2 over sigma 1 and sigma 2. So this is going to equal negative 1 over 162 over, was it 20 over 81 square root, and then the square root of 77 over 324. Okay, and if we simplify this, this is negative 1 over the square root of 1540, which is negative 0.00525. Okay, and so there is then the correlation coefficient, the covariance we found up here, and then all the other values as well. Okay, all right, I think that was helpful, and I'll see you in the next video. All right, welcome back to example 2 for 1 of day 21 in Math 360. In this example, we're looking at a set of random variables, x, that are equal to the number of 1s on a 4-sided die, and y, which is equal to the number of 2s and 3s on a 4-sided die. We're looking at the PMF of this joint probability, and so we have a trinomial distribution, which looks like the following. So we have f of xy is equal to 2 factorial over x factorial y factorial, 2 minus x minus y factorial, and then we have 1/4 to the x, 2/4 to the y, and 1/4 to the 2 minus x minus y for x and y that are in between 0 and 2. And it should be noted that the value of x and y are both positive integers. For the marginal probability, if we looked at the marginal probability of this trinomial distribution, for x, it's a binomial with p equal to 2 and 1/4, with n equal to 2 and p equal to 1/4, and then we have a binomial distribution for y as a marginal probability, which is also n is equal to 2, but the probability of p here is 1/2. Okay, so that's nice that we know that these are binomial with these distributions, because that means that we know that the marginal mean for x is 1/2, and its corresponding variance is 6 over 16. Likewise, mu of y is equal to 1, and the variance for y is 1/2. Okay, with these pieces of information, then it's very quick to find the expected value of xy, which gives us then the covariance is 4/16 minus 1/2 times 1, which gives us a covariance of negative 4 over 16. With this numbers in place, then we can find the correlation coefficient, which is going to be the sigma of, it would be the sigma of 1, 2 divided by sigma of 1 and sigma of 2. Simplifying these numbers in is negative 1 over square root of 3. And finally then, now that we have all of the pieces, we can then plug these directly into the least squares regression line, which is equal to y equal to the mean of y plus the correlation coefficient divided by, or multiplied by the variance, or the standard deviation of y divided by the standard deviation of x times, this is the slope, times x minus the mean of x. And so if we plug in all those numbers that we just calculated, then we find that the least regression, or least squares regression line is going to be 4 minus 2x all over. All right, welcome back. In our last example, for 1 and day 21, we have example 3. And so here our f of x is equal to 1/3 for the order pairs 0, 1, 1, 0, and 2, 1. As you can see, the support for this joint probability function is triangular, which means that since it's not rectangular, x and y have to be dependent. Okay, calculating the marginal means, we have that mu of x is equal to 1 and mu of y is equal to 2/3. Looking at the covariance, we have covariance of xy is equal to the expectation of xy minus the product of the means. Plugging these values in to calculate, you have 0 times 1 times 1/3 plus 1 times 0 times 1/3 plus 2 times 1 times 1/3 minus 1 times 2/3. So of course we get 2/3 minus 2/3 here, which then gives us a value of 0. So here we have the covariance is equal to 0. But again, because the support is not rectangular, the corresponding random variables have to be dependent upon each other. So in summary, rho is 0, but the random variables are not independent, they are dependent. And this is a good example of such a case. Okay, I hope that was helpful, and I'll see you in the next video.